In this video, we are going to talk about some special cases with systems of equations. The last problems that we did were solving system equations, and we were doing elimination. So with elimination, we were trying to cancel out a variable. So in this particular one, we are looking to cancel out the x's. So we multiply the top by a -3 to get to -6, multiply the bottom one by a +2 to get a +6. And so the x's are going to cancel. And then whatever we did to the first variable, we're going to distribute that through everything, and then we'll distribute it through everything down here. And then we got ourselves a y value because the x is canceled. So that meant the lines we're going to cross. Okay, so we have some special cases because when you're graphing systems of equations, lines don't always cross. And so what happens? What are the other situations? So we're going to solve this as if we have no idea, and then we're going to kind of compare it to a visual of what's going on. Okay, so all right, so we're going to take x plus y equals 7. We're going to take the x plus y equals 5. All right, and then let's say we're going to look to cancel our x's. So we'll distribute a -1 maybe to the top. So that gives us a -x minus a y equals -7. We distribute everything on top here. And then we didn't do anything to the bottom. And so we add our stuff together. We're looking to cancel the x's, which they cancel like they're supposed to, but the y's cancel as well. Okay, now we didn't do anything wrong. This was not intended, but it ended up happening. So you have a 0 equals a -2. All right, so as soon as you lose your variables, you have a special case going on. And it's one of two situations. So let's figure out which situation we have. So we're going to take these two equations and we're going to graph them. So I'm just going to do a little bit of adjustment to get these things ready to graph. Okay, so if I bump the x over, I'll be getting the y by itself. So that's a -x plus 7. Right, and then if I do the same thing to the other equation, we'll subtract the x over, and we'll get a -x plus 5. All right, so they're both ready to graph. This one has a y-intercept at 7. And then the slope is down 1 over 1. And if we kind of go the other direction, so that's what one of the lines looks like. Ooh. All right, and then we'll graph the second one. And so that one has a y-intercept of 5. And it has the same down 1 over 1 kind of a look to it. And so these lines are parallel to each other. So the whole point of solving a system of equations is trying to figure out where the lines cross. And these lines don't cross, so they don't have a common point or a common solution for both of them. So since they're parallel, we have no solution. There is no point where they cross. So how do I recognize that over here? Because I don't want to graph it every single time. As soon as I lose my variables, it doesn't guarantee that it's parallel, no solution. But does 0 equal -2? And if the answer is no, then it's no solution. Because there is one other situation. Okay, so you have another special case. Right, we'll take a look at that one. So we're going to solve it just like normal. And we're going to try to eliminate a variable, do all that same stuff. So let's do that way over here. So we'll have the 2x minus y equals 7. We'll have 4x minus 2y equals 14. Let's say we're looking to cancel our x's. So I'll multiply the top equation by -2. So that'll make it a -4, which will cancel with a +4. So -4x plus 2y equals -14. And then the bottom one, we have 4x minus 2y equals 14. Okay, so we cancel our x's like we planned. The y's end up canceling again, so that instantly says we got a special case going on. And then these numbers cancel as well. Okay, so we have a 0 equals 0. Well, that looks different than the 0 equals -2. So there's something else going on. It's a different kind of a special case. So let's graph these and let's get these, let's see what they look like. So if I take this one and I'm going to manipulate it, so I have a 2x minus y equals 7. And I'm going to subtract the 2x over. I still have a negative y equals a negative 2x plus 7. And then we'll divide everything by -1 to make it so it's a positive 1. All right, so negative divided by negative is a positive. Positive divided by negative is a negative. So there's that equation. So that line is -7. 1 up 2 over 1, up 2 over 1, up 2 over 1. And here's that line. Okay, so that line represents all the solutions for this original equation. Okay, so then I'll do the exact same thing with the other one. We have a 4x minus 2y equals 14. We'll subtract the 4x over. And we have a negative 2y equals negative 4x plus 14. Right? And then we'll divide every single piece by -2 to get y by itself. So y equals -4 divided by -2 is a positive 2. 14 divided by -2 is a -7. So if you notice, it's the exact same equation. So if I graphed it, it'd be the exact same line. So we are looking at the same line. And remember that we're looking for what points solve both equations. Well, every point solves both equations. So you actually get infinite solutions of it. Okay, so how do you recognize that here? So if you lose your variables, it's a special case. It's either no solution or infinite solution. So as soon as they equal each other, like 0 equals 0, 5 equals 5, as long as they equal each other, they are perfect multiples of each other. And so they are the same line. So you have infinite solutions. The other one was 0 equaled something other than 0. They didn't match up, and that's no solution. Okay, so that's kind of the difference between them, is if your variables cancel, then you're going to have a special case, right? So the difference is going to be whether you're sitting with variables canceling, but if they equal each other, okay, it doesn't have to be a 0 equals 0. It could be a 2 equals 2, a 5 equals 5. As long as they match, but no variable, you have an infinite solution. If they don't match, again, it doesn't have to be 0 equals -2. But as long as they don't match, then you have no solution because you have parallel lines. And the other one is you have infinite solutions because they're on top of one another and every point works for solves both equations. Okay, so that was our special cases and kind of what to look for when you're solving.